Hello everyone, welcome to a unique recording that is kind of a bit of step up from what we've been learning in all the previous tracks. This recording talks about building a machine learning product, an end-to-end machine learning powered product, in fact, deep learning powered product, and deploying that product into Google Cloud. So this is where the operational side of AI comes into picture. The product that we're going to build is going to help us in detecting the profession of a person based on the image. Right, so first let me show you the demo as to what exactly, how exactly the product is going to look like at the end of this discussion, right? And then I'm going to tell you step by step, what are the steps that we need to follow in order to build a product such as this. So far we've been building machine learning models on Jupyter Notebook. We've been doing expert data analysis on Jupyter Notebook. Now here we are going beyond Jupyter Notebook. Here we are going into a domain where you can actually share the URL, the link to the product that you built using your deep learning or machine learning powered models that you have learned. Imagine, right? Instead of you going through the Jupyter Notebook to explain what you have learned at Apex or what you have learned anywhere, you can just give them an URL saying that now this is a use case where you upload an image and you'll get the profession of the person in the image. How cool would that be? That's exactly what this discussion is going to look like. Okay, so we are going to discuss at a high level as to what are those moving parts, because frankly speaking, there are so many moving parts for deploying a machine learning powered product in the cloud. Right, and these are the moving parts that you'll be grappling with once you join any organization as a data scientist. So you need this exposure in order to understand what are all the things that go behind the doors when it comes to building products like YouTube, Netflix, Google, for that matter. Right, this is the attempt to discuss that. Okay, and this is how the end product is going to look like. So this is the home page of my product. I call the product Eagle Eye because it's going to recognize the profession of a person based on the image. And I just browse, click on browse. I select the image of the person. As you can see here, I'm going to pictures and I'm selecting the image of a judge whose name is Kim. And then I click on upload image. Okay, and now the image is getting uploaded. Image is prepped out for detection. And then once I click on detect the profession, now the machine learning, deep learning model in the backend comes to action. And now it is analyzing the pixels of the image and then trying to figure out to which profession does this person belong to. It is going to take some time, right? And finally, it has told me that it is actually a judge. And then what I'm doing now is I'm uploading this image to further train the model, because this is new point of data, right? Now I selected that, okay, this is a judge. Okay, and I made sure that I upload this image with the right classification, which is the judge, so that the model can use this image, use this particular prediction to further fine tune its model, right? Because had the model told me something like programmer instead of judge, right? Then I can correct the model here. And that's the whole point of this particular page. Here, once this particular page here, right? I select from the drop down what is the actual profession of the image. If the model has told me wrong, right? In this demo, it feels the model is correct, right? And then I'm going to click on train the model so that the model gets updated. Okay, so this is what we're going to build end to end in this discussion. So you're going to upload an image. We're going to call a deep learning model to analyze the image, come up with the profession. We're going to check whether the profession that it has come up with is actually the correct profession or not. And then if it is yes, right, then we're going to update the training data saying that, okay, this is the profession, this is the image, and then it is going to further fine tune it. Okay, so before doing all this, anything, for that matter, anything that we do, right, we need to actually ask some questions. Any deep learning product, any machine learning product, but when it comes to product development, these are the 4 questions that I use to build products which are powered by machine learning and deep learning. The first question is this: does machine learning fit the product goal? So in our case, the problem that we are trying to solve is a problem that many of the background verification companies have, where they want the person to take professional photograph, a photograph that kind of depicts their profession, right? And most of them they don't. and also security concerns. So imagine this, all those shootouts that happen in schools in US, not only in US, across the world, they could be so well avoided, right? If you can, maybe to some degree, if you can only allow authorized personnel. So in a hospital, only doctors should be allowed in a particular area. In a court, only judges should be allowed in a particular area. In a school, maybe only teachers, right? Anyone wearing any other attire, which is not in line with the expected attire for the profession, you can pretty much catch them out, anomalies, right? So this is exactly what we are trying to solve. In order to solve that, what we need is deep learning, machine learning, because humans, we can only comprehend so many people, right? We can only comprehend so many different variations of a particular profession. Whereas a deep learning model, or a machine learning model for that matter, I use machine learning, deep learning interchangeably because deep learning is a form of machine learning, right? Whereas machine learning models analyze thousands of images, thousands, millions of images to understand what are the characteristics of a person who is a doctor, what are the characteristics of a person who is a judge, right? That's exactly what we are trying to do with our deep learning model, right? Does machine learning fit the product goal? Yes, because we humans might mistake a particular person based on his attire. But a deep learning model, because of thousands or billions of images that it is getting trained with, the chance of it making a mistake are less. So the first question, answer to the first question, does machine learning fit the product goal? Is a resounding yes. Now, how does the product behave around machine learning? Right? So it's something like you, because of deploying deep learning model or machine learning model here, will the product behavior actually change? In our case, our product itself is detecting the profession, right? For in which case, we can possibly write all possible rules, isn't it? How many rules will you write? Right? Say, for example, you want to identify a person who is a doctor. How many different types of doctors are present across the world, right? How many different types of mechanics are present across the world? Right? It's so hard, isn't it, to figure out what are those common characteristics that define the attire of a doctor, right? The surroundings in which a doctor actually works, right? So our product takes into consideration the attire and also the surroundings in which the snap was taken. Accordingly, it will identify that the person who is inside that picture is from a particular profession. Okay, so that's how our product behaves around machine learning. We analyze the person and we also analyze the surroundings in which the person is standing in that image. Third question, what exactly are you comparing with? So we are comparing with human level accuracy. So we humans, if given some time, right, given some training, we can, our eye is really good when it comes to identifying this kind of information from an image, right? So what am I comparing with? We are actually comparing with human level accuracy. Now we want to strive for that accuracy so that this machine learning model can operate at scale. And the final question, how quickly should the product change? How quickly should the product change? How quickly should the model get updated, get feedback? May not be real time, need not be real time, isn't it? Even if it is making mistakes when it comes to identifying doctors, you have to train it not real time, maybe every day or maybe once a week. Right? That's how quickly your product should change, because this is a slow process, just like a kid, right? Who eventually learns from all the mistakes that he is making so that he eventually gets it correct at a later point of time. Right? How quickly should the product change? Product should change, but need not be real time. Right? This is also the same case with, let us say, YouTube recommendations, Netflix recommendations, right? The system should improve, but you're not looking at real time update, isn't it? Whereas share market, share price prediction, that has to improve real time, because any mistake in share price predictions, you're losing money, right? So these are the four kind of questions that there are overarching questions that can help you take the right decision when it comes to building a machine learning or deep learning powered product. Okay, now that we have answered these questions, let us look at the approach that we're going to follow to build these models. We are going to first build an image detection model on Google Colab and train it with my data. So Image AI is a library that is available from a kind soul who has shared it on GitHub. I'm going to use that library for training purposes, and the images are uploaded to Google Drive. All the images, right, along with the folder names. which denote the professions, right? They're all uploaded to Google Drive. I'm going to shortly show how that is going to look like. And then that is the training part, right? Now, how do we use it? How do we make sure the end user interacts with this model? For that, what I did was I wrote a Python code snippet that takes the input image from the end user and make the predictions about the profession of the person in the image. I wrote a Python Flask script, right? And then I created the necessary HTML file so that the minimalistic UI that is needed for the end user to interact with this application, right? And then provide his feedback, just like the video that we have seen, right? And then the fourth step, which is probably the step that is the most time consuming and also at the same time the most important. How do you operationalize this, right? If I'm just deploying it in my local machine, only I can use local host, right? Only I can use. How can you share this URL with your brother who is in Australia, or with your father who is sitting somewhere else, to show the product that you have built, right? You need to upload this into a public domain, public URL, right? That is where Google Cloud comes. We are going to deploy our deep learning model in Google Cloud. I'm going to show you step by step how you actually do that. And then the final step is, once you deploy it in the Google Cloud, take feedback from the end user on the predictions made by the model and retrain the model periodically. That's the final step, isn't it? How quickly should the product change? So that maybe once in a week, once in 10 days, you retrain the model so that your goal is to always improve the model as much as you can. Right? So this is the approach. First, to build image detection model on Google Colab. Why Google Colab? Because it is the fastest. We use a GPU to actually analyze these images. It took me 18 hours to train this model on Google Colab. Right? And then once you train the model, you download the JSON file, and then you write a Python code snippet to make the predictions. Right? And then you create the necessary HTML files and build a Flask application. I'll show you how we can do that. Finally, you deploy the Flask application in Google App Engine, and then you take the feedbacks, make the URL available to everybody, take the feedback from the end user and predictions made by the model, and retrain the model periodically by incorporating the end user feedback on new images. Okay, now let me show you how the data, how did I get access to training data and test data, right? So iDenProf is a folder that I upload Google Drive. This is the folder that I got, right? This folder contains all these folders here: training, test, models, and JSON. Let us go to train. In the train folder, under the train folder, I organized all the training images into professions: chef, doctor, engineer, farmer, firefighter, judge, mechanic, other, pilot, police, waiter. Right? I organized all of them based on professions. Right? So the original training data set that I have contains pilot, police, firefighter, farmer, engineer, doctor. I added the extra folders, right? Judge, mechanic, waiter. You can also add your own folders. Right? Now, if you click on, let us say, mechanic folder, right? So these are all the images that correspond to mechanics. These are all the images that we are putting in this folder, and we're asking the machine to figure out the patterns across all these images, right? So for each profession, I have 1,000 images. It was a lot of work getting all these images on board, right? But that's exactly what, as a data scientist, we are supposed to do, isn't it? We are supposed to be the people who pass the right kind of data to the machine, right? So you have, as you can see, it's not just attire of the person, it's even the surroundings. Based on surroundings also, you're actually looking at what kind of profession are we talking about, right? So this is the train folder. This is how the train folder contains. Okay, now let me come to the Colab notebooks. If I go to Colab notebooks, right, and then I see image recognition. So this is a Colab notebook. I'm going to open with Collaboratory. Right, this is how I trained the model. So now, first things first, I downloaded all those images, I organized them based on professions, and then I used this particular Colab notebook, which I named as image recognition, right, to train the model. In Colab, there are a host of packages that I need to install. I'm going to explain what each package does. Right, first import Oh yes, first I'm going to use pip install, right? This is how you use pip install in Google Colab to import all the packages. PyDrive, which helps me access the folders that are there in Google Drive. All these folders, right, are there in my Google Drive. Right, so PyDrive helps me access all those folders. Install TensorFlow, OpenCV, another library that we are going to use for effectively identifying images. Right, you have Pillow, H5py, right, Matplotlib, Keras, and this is the repository from which I got the ImageAI package. The ImageAI is the package, Python package that contains underlying deep learning algorithm. And the underlying deep learning algorithm is nothing but ResNet. Okay, so what exactly is ResNet? ResNet is a high-level variation of CNN model. It's an award-winning paper as such, this ResNet algorithm. So what at fundamental level, you're going to learn more about this during in the deep learning track about CNN, ResNet, and everything. But at a high level, what ResNet does is similar to how we humans don't really go through all the pixels of an image sequentially to understand whether we're looking at a lion or whether we're looking at a frog. We take shortcuts, isn't it? We just look for those patterns that will give out the answer, whether it's a lion or a frog, right? We use shortcuts all the time whenever we're trying to recognize. That's the reason why we don't really read all the letters of any word in a website that we're looking at, right? Any paragraph for that matter. We don't always read all the letters of a word. We kind of read, maybe if it's a huge word, maybe we'll read 3 or 4 letters, right? Maybe if it's a 15-letter word, and then we try to figure out, we try to predict that what the word is all about. We kind of get it, right? We don't read the individual letters of the word da, right? We just see that that's a pattern, and we use shortcuts to move from that particular word to other words. But even if some of the words spellings are wrong, our human brain is so good that it can still figure out what the actual word is. The same logic they use in this algorithm called ResNet. So what they're trying to do is using a deep network. As you can see, this is how the network looks like. They're using shortcuts between different layers of neurons so that they will identify different pixels. And just like how human brain comprehends images, they're going to do the exact same thing here. Right, so this is a beautiful link that contains the explanation of this algorithm in great detail. You can have a look at that. Right, I collected all this information, collected packages, and then I imported PyDrive. So Google Auth, Google Drive, these you require to connect to the Google Drive because Google Drive contains the folder, right? Identify the provision. Right, if I scroll down, as you can see here, this is where I'm mounting content. I'm actually going to that folder, right? And this is where from ImageAI, right? Whatever I have just imported from GitHub, I started training. And here I can say, right, the number of experiments that I have to complete. I have to put it to run. I'm creating a model. Enhanced data, batch size, 32 images at once. That's what I'm giving to this model. And I'm also showing the network summary here. This is how I can see the network summary. This is the number of layers that I'm using, right? And this is how I'm going to train the model, right? And then what I'm going to do is I'm going to train this model, right? And then that model, whatever the model that I've trained, is going to sit here under the models section, right? So this is the model. I had the model in HT5 format, trained_model in HT5 format, and JSON file that corresponds to the metadata of this model. So these are the 2 files that are important to me. Right now, I'm not going to train the model because I already trained it, right? But you guys can just give it a shot, train the model as it is. Okay, and then what we're going to do next is, now that we have the trained model class, trained model, and everything, right? We are going to make some predictions. In order to make predictions, what we are going to do is we are going to have a separate notebook which contains the prediction aspect. Okay, so let me just come over here. Colab notebook, image prediction. Again, I'm going to open with Collaboratory. Collaboratory is fast. There's only solution for you to actually build your model. Right, and again for prediction also we import the necessary packages, but prediction code is simple, right? So what you need to do is you just need to pass Let's set the JSON path to the metadata of the model that you have trained, and then set model path to trained underscore model. So make sure that those, the H5 files and the JSON file are in the same path from where you are running this predict method, right? And then you are getting the predictions and probabilities. You have this method called predict image, and you are going to give input as the image, basically the image of the person that you are trying to classify, detect the profession, right? And you are giving result underscore count equal to 3. Basically what this will do is the model is going to look at the top 3 professions to which the image maps, and it is going to give probabilities also, right? And you're going to print out the probabilities. Right now this image kim.jpg, as I showed you, belongs to a judge. 100% is 100% sure it's a judge, and there are also 2, I mean, slightest of slight chances that they might also belong to firefighter and police. So we just round it off to 100. Okay, so this is how the actual prediction happens. This is how it happens in the Google Colab, right? You create a notebook, IPNB notebook, and you make the predictions. All this is fairly straightforward, right? Still, we are living in the world of Colab, Jupyter notebooks. But then our goal is not that, right? We have done the POC part, correct? We've done the POC, we actually built a notebook, right? And we have built a model that is actually working well. Big thumbs up for us. But the real problem is, real goal is to actually build a front end that can consume these models in the back end, right? That's what building a machine learning powered product means, isn't it? Now, how do we build a front end, right? In order to build a front end and deploy this model in the back end, you need to have a clear idea as to the flow of the application that you're going to build, right? What should be the home page? What should be the direct navigation path? When should I go from navigate from the home page to another page, and what should be the another page, right? And what should be the subsequent flow, right? How do I build an end-to-end application that tells me this flow? That's something that you need to think about. Okay, that's exactly what I'm going to show here. So there is, I first crystallized all this information into a local Jupyter notebook, right? Because collaboratory, I use collaboratory just to create the training model, right? So basically train the model so that it identifies the images. But now in order to build the front end, what I'm doing is I'm building a Flask script, Flask application, right? So in order to do that, what I'm doing is this, right? So first things first, I need to have the home folder ready. I need to have the home page ready. I need to have the other pages ready, right? For that, what I did here is I go to desktop, go to Eagle Eye, and here you can say that whenever using Flask, that you know how to use Flask, isn't it? There's the other recording that talks about Flask. So Flask works in this manner. Import OS from Flask, import Flask, render template request. These are the 3 methods, right? And I'm creating a Flask app equal to Flask name, right? I'm mentioning the app, upload folder, some folder, app config, upload folder. Okay, there's a folder where I'm going to upload images to. And here is where I'm defining the navigation part. When I say @app.root/, what this will do is it will help me navigate to the home page. So what do I mean by that? Let me show you. First, let me execute this part. Okay, it will take some time to execute because these are like heavy lifting libraries. So what Flask up? So first thing, so the first step is getting the training part out of the way. You got a trained model, right? Now this is where the second step starts. The first step is exactly what you've been doing in your machine learning track and the things that you've done in the data science foundation track. The second step is where you are trying to get the front end working, right? As you can see here, now I'm working, and the moment I ran the Flask script, right? When I say @app.root, right? Basically, what is running this instance is this, the main method. What main method is doing is it is started a web server on my local machine, HTTP 127.0.01, 5000. Now if I click on this, right, now this will direct to the home page. Let us see where this is going. Right, it will take some time. The 127.0.0.0.0.1 5000, that's the port on which this has opened up, right? And then which page should it render? It should render some HTML page, right? That's exactly what I'm saying here. Return render underscore template home.html, right? Now where is home.html file? This is how it should work, right? Basically, wherever is this eagle-eye.ipmv, the Jupyter notebook that you are running the script from, that should contain this folder eagle-eye. Right? Eagle-eye is the folder. There you should have a templates folder, and in the templates folder you should have the home page, right? And this home page that I'm writing, it is extended from a framework called layout.html. Okay, I'm going to show what layout.html is, right? Let us see how this looks like. It's going to take some time because my machine is a bit slow on this, right? This layout.html contains nothing but it is extending. That home.html is actually extending layout.html, right? So this is exactly what layout.html is. Layout.html contains a layout, that is the layout that is applicable to all the pages in the Flask application. Because every page is going to extend this layout.html, right? That's exactly what this is doing. Layout.html file is a simple HTML file. It has the head, it has the title, it has the script. I'm using the Bootstrap CSS directly, so I'm calling it there. And then it contains a logo and it contains the URLs for home, about, and the details of the model. So this particular link contains the GitHub link, which contains all the information about the page, right? So these are the links that this information is available as part of every HTML page that extends this layout.html, right? Now home.html is extending this layout.html, and then what it is doing, it is creating, right? It is detecting, it's creating a form action, upload action, right? And it has a browse option and upload your image button, right? Browse and upload your image. Right? That's exactly what you're seeing here. Now the page has come. Why did it come to this page? Because that's exactly what you mentioned, app.root. Right? Whenever somebody hits on 127.0.0.1 5000, right? You direct that person to this page. Right? That's exactly what you have mentioned here. Return render underscore template. By default, it is always going to look at the templates folder. So whichever project that you're creating, always ensure that all the HTML pages are placed in this templates folder. I just placed all my HTML files here. Okay, and this is the home.html. Right now, what I can do, I can go to the eagle-eye folder. Just give me 1 second. I go to eagle-eye folder. Right? And then what I'm going to do, I'm going to first browse. Right? Let me just select an image. Let me select this person, mechanic. Okay, and I click on upload your image. Now, where should it go? It went to upload folder, right? How do I know it should go to upload folder? Because once I uploaded the image here, right? Once I click on home.html, so in the HTML file here, right? Upload your image, right? So it should go to upload. That's what I mentioned in the action part for the form. So once I uploaded that image, right, it should go to the, it should check for the upload file in the templates directory. That's how it knows. That's how I'm directing it, right? Once it goes to the upload method, right? Once it goes to upload, so basically what is going to happen here is it is going to render these files. So upload is the method that I'm mentioning here. That's the form action equal to upload. What it does is it directs to the upload app root. Right, now it has come here, upload app root, and here what I've done is request.files image. What is request? Request is nothing but I clicked on submit here, isn't it? Upload the image, I clicked on enter, right? Whatever is the payload from that page, I'm getting that here under the file. Basically, I'm getting the image that I uploaded here in the file variable. And then what I'm doing is I'm just renaming that file name to test.jpg. Okay, and I'm returning success.html. Now, what is success.html? Let us see. If I go to templates, again, everything I'm keeping in templates, right? If I go to templates, then we click on success.html, right? You can see that image is prepped up for detection, right? You have a submit button. Do we have that now? Let us see. We have the submit button here, detect the profession, right? Now, this is how I've directed it. So image is prepped up for detection, detect the profession. Now, where will this go? If I click on submit, it will go to classify. Form action equal to classify. Now it will go to the classify method, right? Where is the classify app root? Here. In the classify app root, that is where the prediction is going to happen. Right? It is going to look at the prediction. It's going to, as you already seen, right? I got the model class and trained underscore model also in the eagle eye folder, right? Trained model.hy file and the JSON file. I have this data also in eagle eye folder. Now what is happening here? It is going to, whatever is the training code, I just replicated that here, right? And then finally, it is going to print the profession. I'm going to look at the maximum probability. I'm going to return only the maximum probability value. If it gives me 3 professions with 3 separate probabilities, I'm only worried about the profession with the maximum probability. Right? And then it is going to return result.html, right? That's exactly what's going to happen here. If I click on detect profession, now the deep learning model has been called in the backend. And now it is working. It is working it off, seeing how it can get that information up here. Right? Now it is it's analyzing different pixel values, and it correctly said it's a mechanic. And which folder did I give? Which image did I give? I gave this mechanic image, mechanic-2 image. Right? And it correctly predicted that it's a mechanic, isn't it? Right? And it is a classify folder, and it is nothing but the success. Right? If I just go to eagle eye, templates, success. Not success, right? Result, I guess. Right? The result.html file, it contains the output. It is a mechanic. So I'm getting the profession value, right? How am I getting the profession value? Look at this. Look at this part here, right? Once I get to classify, what I'm saying is return render template result.html. Also, I'm passing the profession value here. How did I get the profession value? Profession equal to max results, comma key equal to lambda k results k. Right? So whatever is the profession that has the highest probability, I'm passing that here. That profession equal to profession, right? And then this is how you refer to values that you pass from one HTML file to the HTML file, right? To flower brackets profession. Okay, now that is exactly what we have done here. We have uploaded a model, and in the backend, right, the ResNet algorithm has looked at different pixels and figured out that because he's dealing with a car and because he's wearing an apron, which is a mechanic's dress, it figured out that it's a mechanic, right? And this is the file, the result.html file that we are rendering once we click on classify. App root classify. How do you know that it went to classify? Because earlier in the success.html file, when we wanted it to predict the profession, we directed to classify, right? And result.html file. Now, what if I want to click on train the model? Now, where should it go? If I click on train the model, if I click on train the model, it should go to the action train, right? So it should go to action train, which is nothing but in the eagle eye, right? If you so app root action equal to train, this is how it is going to look like, right? Slash train, right? That's exactly what is going to happen here. If I click on train the model, right? Now it is going to ask me where the model is going to be. Training the model is nothing, but now I need to update the model, right? The training data for this model with this image, with this new, even though it got it correct, right? It's a new image that the model has not seen, right? So now what I need to do, I need to keep this image in the right folder, right? So that's exactly what I'm getting here. I see all the different, in the drop down, I see all the different professions: judge, mechanic, farmer, engineer, doctor, firefighter, chef, pilot, police, waiter, other, right? I just select mechanic. And how am I getting this page? Because I know that under the train method, it is actually rendering train.html, right? Let us see what train.html file contains. If I click on train.html file, right, you can see I gave a selection. Again, it's a minimalistic UI. It can be fine-tuned. This is the first kit, right? First version of this product. I'm going to fine-tune it at a later point of time. Right? I just gave hard-coded all the professions that I have available in the select menu so that the user can select one of these. If the profession, you upload image and it is unable to come up with the right profession, what you can do is you can select other, right? And then input submit train. And once you submit, it should go to the update method, right? Update app root. Right? So once I click on train the model, now what it is going to do is it is going to update, right? There is some error, but we'll see what the error is, right? Error is also fairly straightforward, I think. Import numpy, right? NP is not defined, right? Let me import numpy as NP. I didn't execute that, right? So that part I need to take it. Okay, that should be taken care. It's not a problem. Right, so basically what's happening here is now it will go to update method and see what's happening in the update method. If request method equal to post, what I'm doing is first I'm extracting the profession information, right? How do I have the profession information? Profession information is part here, right? I'm extracting the value that you have given for the profession during the drop down selection, right? And I'm storing that in the text value. Right, and then what I'm doing is I'm using the JSON key file, right, that I downloaded from Google, because I need to, where do I need to upload this image? I need to upload this on Google Drive, isn't it? I need to upload this on Google Drive here. So basically, whatever image that I have come up with, that the new image that I just showed you, the mechanic image, I need to go to identprof and I need to actually upload it in train under the mechanic folder. Right, in train under the mechanic folder, right? So that's exactly what we are going to do now. So now what we're going to do is this, right? In order to connect to the Google Drive, I don't want to again enter the credentials and all that stuff, right? It should automatically happen without any involvement from my side, right? That's the reason what I'm going to do is I'm going to give service account credentials from JSON key file name. So it's a JSON key file that I already downloaded. It's already here, right? Once you have the Google Drive, I'll show you how you can download these credentials from Google App Client Secrets. I'll show you once I go to Google Cloud Console in the next recording, right? And then what I'm going to do here is I'm just building a drive service so that I can directly upload to the drive, and this is going to help me. Basically, this is the line that is going to help me authenticate with the file, and I just stored the text value in the form of name, and then I'm telling where do I want to upload this image, right? Application/vnd Google Apps folder. It's a folder where I'm going to upload this, and the message part, right? So basically, actually what I'm going to do is I'm going to use this drive_service.files method that is provided by b.Write, and I'm going to upload this image to drive, right? By giving these fields. Okay, and then this is how I'm also changing the file name. The file name that I'm actually using, I'm also changing the file name, because what I need to do is basically name the file as something like mechanic-3456, something like that. Because I already changed the name of the file, right? Not always your file name will contain the profession name, isn't it? Here for demo purposes, I have the mechanic-1, but most of the times you might upload your own image, right? Which might be of some name, like your name. But I want to name that image so that it is in line with the naming convention of other images in that folder. right? That's what I'm doing is I'm generating random numbers and I'm attaching that file name here. That file underscore name str equal to np.random brand int. Okay, and file underscore metadata equal to name text plus file name plus jpg. So basically I'm passing the metadata as to what is the name, what should be the name of the file, which I'm getting from this random number. So how the file name will look like is like this. The file name will look like mechanic some random number 253675. Right, so how do I know it's a random number? Because I have file name here, right? I'm generating a random number every time so that it follows the naming convention. This is how the name of the file will be stored in the mechanic folder, right? And that I'm sending that file here, and then file equal to drive service.files create, right? I'm actually sending these files to the Google Cloud, and then once the file upload is successful, I'm actually rendering the file upload.html file. So let us see how the file upload.html file look like. Go to Eagle Eye, templates, file underscore upload. Right? Image uploaded successfully to the training folder and submit. Well, this is if you get this page, that means this series of instructions, which I'm going to spend more time when I'm explaining the Google Drive functionality, Google Cloud functionality in the next recording, right? So what these functions are doing is they are uploading this image to the right folder, the folder that goes by the name that you just given. Right? How am I getting that folder? Here, I'm getting the folder ID. Right, I'm getting the folder ID based on the fact that you are passing the text, this particular provision, name equal to text. Right, that is how I'm getting the folder ID, and I'm directly placing in that folder. Right, and then that is how you are building this app. So as you can see here, mechanic, it is 97.04 for this particular image. Firefighter is 2.95, and engineer 9.2 into 10 to the power of minus 5. Right, so it has given attached the highest probability to the fact that that image contains a mechanic, firefighter, and engineer. Okay, so this is what is happening at a high level. So now let us fix the error that we got earlier, which is numpy, import numpy as np. So I just added that particular statement, import numpy as np, so that this particular statement works. Okay, now let us go back and start this server again. Right, so I'm just clicking on, once I'm running it one more time, so that you see how the flow is going to be for uploading an image. It's going to take some time initially to get it started. This is a problem with running a web server on your local machine, because so many processes are already running. Right, it will be slow. That's the reason why in the next recording we're going to go with deploying this in the Google Cloud. I'll click on browse. I'll again go and select the same folder, mechanic-2. Right, I upload the image. Now image is prepped for detection. Date the profession, it will say it is mechanic, as we already seen in the previous discussion. It's going to take some time. Now you can see also the fact that these are machine learning products, right? This can't take so much time because it is actually passing it as test data to the deep learning network, and deep learning network is trying to come up with the right prediction for the profession. It's going to take a lot of time, right? But in Google Cloud, we're going to see that it's significantly faster. And then we're going to click below to train the model, right? Now I enter the actual profession, it's mechanic, train the model here. It will take some time, right? And now the image is uploaded successfully to the training folder, right? We'll see where the image has actually come to, right? So as you can see here, this is the train folder, come to mechanic, right? And then that folder, that file is uploaded here. Okay, let me just go to my drive. It'll take some time for the folder to actually show up in your Google Drive. As you can see here, mechanic 1605. Right, if I just open it, as you can see, it's a random number that got attached to this image. Right, mechanic 1605, and this particular image is in the mechanic folder. Right, let me click on the details part so that you can see the folder also. Show file location. And you can see it is under the mechanic folder. This is what we wanted, isn't it? We wanted all the mechanics to be grouped into the mechanic folder. That's exactly what happened here. Right? Now, what we have done so far is we have created, we have built an image, as you can see here. But here is where it just slotted in. Right? We have uploaded an image. We have seen what the image, the profession of the person in that image is, and then we ensured that we selected the right profession so that we are retraining this model. Now, what I can do, now that the image is here, I can go back to image recognition, this training model, and maybe at the after 1 week, right? Once a lot of people have uploaded their images, also give feedback as to whether the model, whatever the model has predicted, is whether it is correct or whether it is wrong, and then I can decide to actually run the model again, right? So that the accuracy will keep on increasing with the course of time. Right, and this is the answer to the fourth question: is it how frequent should the product change? The product, I don't want the product to the training to happen in the back end, because this is a machine learning product that we're deploying. We don't want the end users to wait forever when the training is happening in the back end, right? It can happen offline, completely in separate system altogether. That's how Facebook, YouTube, Netflix, all of them operate, right? That's exactly what we have done here. Okay, to summarize, what we have covered in this particular recording are these steps. We built an image detection model on Google Colab and trained with my own data. We wrote a Python code snippet that takes the input image from the end user and made predictions about the profession of the person in the image. I created the necessary HTML files and built a Flask application, right? And then I also seen locally fifth step, how feedback from end user is taken and how the model can be retrained, right? Now, in the next recording, we are going to take it one step further. We are going to deploy this Flask application in the Google App Engine. I'm going to show you how you need to set up your account, right? Step by step as to what are the different things that you need to model. I kind of briefly touched upon it when I'm discussing the model method here. Upload method here, upload images, right? So this is the update method, right? So here I mentioned some of the things that are happening. And once I upload this to Google Cloud, that I'm going to show you exactly what's happening there. And how do you start the app? How can you monitor this? What are the things that you need to take into consideration when you're deploying it to Google Cloud, right? And what's the way forward after that, so that you can build your own machine learning model, the machine learning model that you've learned in your track, all the expert data analysis models that you've learned in your Retrain Foundation track, how you can deploy them to Google Cloud and make them accessible to everybody else. That's what we're going to focus in the next recording. Okay, awesome. Hope you guys enjoyed creating this stuff, because there's nothing like creating, in my opinion. You're actually creating a product. You're actually implementing an idea, right? That is going to be the future going forward. You're not just going to be limited to building machine learning models. And as you can see, I did not take into consideration any complex HTML also. It's like as minimalistic as it can. You might think that I can do better than this. You certainly should. So think like that. You should certainly think like that. Because it's minimalistic UI, because my goal here is to show the end-to-end application, right? How you operationalize AI and how you can better improve the UI aspect of it by using CSS designs, everything. I leave it to you, right? You guys know how to do it. You guys are far better at it than a person who is not into HTML and CSS web development, and you guys can develop it the way you want. But the important thing to notice here is how do you connect all these things together, right? So first we trained the model on Google Colab, we downloaded the model, and then we wrote Python. We built a Python Flask application that has a bunch of HTML files that take input from the end user as an image, right? And then sequentially direct the end user to see the output and also train the model with this new image and the output. Right, and then the next recording, we're going to focus on how we deploy all this, how we take all this and put it on the Google Cloud so that it becomes available to everybody else, and then so that we can see the end-to-end video that I showed at the start of the discussion. I recorded that video after I deployed this application onto Google Cloud. Okay, awesome. Hope you guys enjoyed this recording. Until next time, this is Sai signing off.